Okay, good morning, everyone. Got a number of people arriving right now, so we'll give it about 60 seconds and then get started. In the meantime, if somebody can type into the questions, it's questions and chat, I think. Just type in yes if you can hear me. It'd be nice if someone can do that. Just type in so I can confirm that we have audio. Very good, thank you. We've got audio. So give it about 45 seconds more and then just get started. Okay, everyone, thank you for coming. Let's get started. My name is Daniel Filestra, and this webinar will be about forecasting, data mining, and machine learning using Analytics Solver for Excel. So you can do all this work in Excel itself. And we'll also talk about deploying your data mining, machine learning, forecasting models to the cloud using our Rayson server. And you can do quite a variety of things working with Power BI, working with Tableau, working with Microsoft Teams. The usual presenter of these webinars, and you probably have received some emails from her, is Dr. Seema Maleki. Seema has been out of the country for a few weeks, and so I've stepped in to present this series of webinars. But Seema is returning shortly, and just wanted to show you where our next series of webinars can be found. The next one will be a optimization webinar on September 15th at 7 a.m. Pacific time, GMT minus 7 hours. You can always find these by simply going to solver.com and then going to the Learn menu and clicking on Training Webinars. And you can pick any of the three or just go to the main page here. But for today, we're just going to dive right in and talk about forecasting and data mining and machine learning using Analytics Solver in Excel, and then later deployment to the cloud using Rayson. So here's what we'll cover. We want to talk about first how to model and solve problems which are typically classification and prediction problems using data mining and machine learning. We'll also cover time series forecasting in Excel using Analytics Solver. We can use both desktop and cloud versions. We'll spend actually the majority of our time on that issue because that's the most common case for our customers. But we also want to talk about how you can deploy your predictive models using the Analytics Solver deployment wizard and create cloud services that can then be used in other applications, used from Power BI and so on. You're making the results of your work available to other people who might be geographically distant from you or distant in time zones. So as it says here, we'll talk about moving beyond analytic models in Excel to work in Power BI, Tableau, or your own server-based or desktop or even mobile applications. Okay, so we'll be talking about primarily these two different tools. On the left, we have Analytic Solver, which runs as a very powerful add-in to Microsoft Excel, both Excel for Windows and a version does run in Excel for the Mac, and a version runs in Excel for the web. And those latter two versions are what are called a modern Office add-in that will work, in a browser as well as in desktop Excel. Analytic Solver can be used completely by itself. That is, you can train a machine learning model. You can fit a forecast to seasonal data, and you can use those models to then make predictions or to do what we call scoring of new data. Similarly with Analytic Solver, because it's a very comprehensive product for analytic model building, you can build mathematical optimization models and Monte Carlo simulation and risk analysis models using the same software. And there's one more area: you can build models which consist of multiple business rules in decision tables, interlinked decision tables. Some of those decision tables can use predictive models as inputs, and that's another domain that Analytic Solver covers. It's the domain called business rules and sometimes called decision intelligence or decision management. Rayzon, which you see pictured over on the right, is we're looking at Rayzon through a front-end portal, which is at rayzon.com. You can visit that anytime. Now, that rayzon.com is just the front-end portal to what in the background is a REST API service that can be used by any application. Rayzon.com is really just an application using the back-end service, it's at rayzon.net, exposes a REST API and allows other applications to perform optimization, to analyze and solve optimization models, to run the Monte Carlo simulations, to even fit and train machine learning models, all in the background in the cloud where you present some other user interface, and then execute, like invoke a trained model using to score new data. Okay, so we're going to talk now just about the sort of the methodology that's involved when you are working with forecasting and data mining machine learning, as opposed to optimization or simulation. It's a little bit of a different process. So let's just talk about the basic steps. The most fundamental step is that instead of building fundamental difference is that instead of building a model with formulas that relate your decisions to, for example, in an optimization model, relate your decisions to some objective you're trying to maximize or minimize, and to some constraints where you're trying to impose certain limits. Or in a simulation model, you constructing a model with formulas that describe the behavior of something in your business or other work that is influenced by uncertain factors like interest rates or just plain old demand or something of that nature. In a data mining or machine learning context, we are basically trying to build a model that can do prediction, or as a special case of prediction, classification. And I'll explain what I mean by classification in just a moment. But to do that, we've got to have some data, and the data typically reflects a number. The larger number, the better usually, a number of past cases. So you need to organize your data in a specific way, basically in a conventional table fashion. And just to remove any mystery from the slide here, I'll just bring it. Here's a very simple table, which has 6 columns and a bunch of rows, and every row is a different instance of a particular kind of flower, and it's measuring the petal length and sepal length in those flowers. That's what I mean by a table. Here's another one. This is a wine data set where there's more columns and different properties of the wines, and each row is an example, an instance of a wine. So that's the sort of thing that I mean. All right, so your rows then are cases or observations of the situation you want to predict, classify or predict. Suppose you're trying to predict a machine failure for some kind of production line machine. Then every row would have to be what you were able to measure at the time or just in advance of the time the machine failed in the past. And then columns, as you could get an idea from the Excel examples you're just looking at, the columns are observable, are quantities. Sometimes they're called variables, sometimes they're called features, sometimes they're called attributes, and they're known at the time you want to make your classification or prediction. So maybe properties of the machine just before it failed, looking for warning signs. Think of an online transaction and you want to diagnose or you want to predict whether it's fraudulent or not. You'd be looking at where the transaction was coming from or the internet, and what that told you about the geography, that makes sense for the actual credit card owner. Was the amount and other characteristics like that. So columns are variables or features. So then having organized the data in that fashion, typically there's actually some further steps. So the very first step is to organize your data into what we sometimes call a data frame. And that's just what I described above. Columns are features, rows are cases. Then there's often some more work to do because data is rarely, if ever, that clean. So you often spend a fair amount of time cleaning up the data. There are a lot of tools for doing that. You could use SQL, and so on. Analytics Solver has some tools for dealing with the data, typically when it's already at the point where you've got a table of data, but maybe there's some missing values, blanks where there should be numbers. And so we'll do what's called missing value imputation, where there's a blank value, we'll substitute like the mean or median value from that column just to fill it in so we can perform, once we've done that, we can perform a further analysis. You can convert some kinds of string values into numeric values, and you can do binning of continuous numeric values into bins or categorical values and so on. Once we've done that, then we want to be able to evaluate the performance of a model that we fit or train to the data. And if you use all of your data just to train the model, then you have nothing with which to validate it later. So typically we'll want to take our data rows, our observations, and select a subset of them that we're going to use. We're going to feed to the machine learning algorithm or the forecasting method to fit the data, to fit the parameters of that that prediction model. We're going to fit the parameters of the model to that data. Then we're going to evaluate the performance of the model on held out data that has not seen before. And that's what we have in the validation set. Analytics Solver, you'll see, has some convenient facilities for partitioning your data. Once we do that, then we apply a machine learning algorithm. So we do, typically in one continuous step, we fit the parameters of the machine learning model to the training set data, and then we validate it, we check it by running the predictions off of the validation set data and see how we perform. I should probably say at this point that, and then finally, let me actually say the last step is put on your thinking cap and analyze the results and think about what it all means for you. Now, most of what I've described here is what we call supervised learning in the machine learning world. And in particular, for supervised learning to take place, we need past instances of past observations or cases where the outcome that we're trying to predict or classify is known. So in this data set, this is actually the species name, and we've got a number of cases where we measure the petal width, petal length, sepal length, and we knew what kind of flower it was. Setosis, versicolors, or virginicas, 3 different species. In this wine data set, this is the vineyard from which the wine came. There's vineyards A, B, and C, and we have for each wine we have these measurements. But it's important that for supervised learning to happen, we have some past cases where we actually know what vineyard it came from. We're going to build a model so that then if we encounter new data, we know that the right outcome is going to be vineyard B here, but based on that new data, the algorithm can make a appropriate classification. Okay, so putting this up one more time just so you can see the steps involved. Now let's actually jump in and do it. Okay, so back in Desktop Excel initially, I wanted to start with this very simple data set just to illustrate the simplest steps. This is actually a classic data set. It was used by very famous statistician R.A. Fisher when he introduced the method, which he had sort of invented, called discriminant analysis, and he used this as an example. Ironically, in one of these back in the 30s when they were thinking about eugenics. So let's go ahead and try this now in Analytic Solver for Excel. And the very first thing we're going to do here is just explore the data. That is to say, we're going to look at the data, and we'll use a few chart tools to enable us to do that. So here, Analytic Solver has a chart wizard. Now you can perfectly well use Excel charting as well. Analytic Solver primarily tries to give you some certain chart types like parallel coordinates and scatter plot matrix that you wouldn't find in Excel. Let's go ahead and try a scatter plot matrix here. Go to the next choice, and what we want to actually put as a chart are just these 4 measurements. These other 2 things are just Setosa or Virginica or Versicolor. All right, now let's go ahead and let that draw. And let me enlarge it a little bit. And so what's happening in this scatter plot matrix is on the diagonal, we just have a bar chart, frequency plot, if you will, of all of our observations. You know, what was the petal width, what was the petal length, sepal width, and sepal length. And off the diagonal, we have a scatter plot. So this is petal width versus petal length. This one is petal width versus sepal width. Let's take this one here. This one is petal length versus sepal width. So we have all these different scatter plots. Now we can do a little bit of just exploration right here, like something you might be curious about is what's going on in this little cluster down here. You can just select that, and then now we're going to do what's called brushing. So I select all those points, and Analytic Solver colors all the points in the other charts, all the same corresponding points, the same color. And what do we see? We see that there's a group of flower observations where the petals are short, petals are narrow and short, so they're small in both the width and the length. On the other hand, when we look out here, where we're looking at, we're looking at sepal width and petal length, that's all spread out. And so these are the same points. Whatever these flowers were, their sepal widths are all over the map. And then another thing we can see even from the bar charts here is that there is a cluster of the same flowers that have both, short, small petal widths and small petal lengths. Okay, so having done that for a while, I'm just selecting a different blank area here to remove the brushing effect. Now, one thing we can do is we can, if we have a categorical variable, we do here, we have species name, for example. If we just now color all the points according to species name, then we actually see something jumping up at us right away, which is all these are now light blue, and those are actually, I think those are Virginicas. And it's, in other words, there is one species, and that species are the ones that have, very small petal widths and small petal lengths. And that gives us a strong hint about how a classification or prediction algorithm should work. And indeed, if I'm just going to ahead discard this. Something else you can do, and it's more interesting when you have more columns. Let's do feature selection even on this small data set. Our outcome variable can be either species number, which is 1, 2, 3, or species name. And as soon as we select that, it says, okay, a categorical variable with 3 buckets. And then we'll pick these 4 things as continuous variables. Now, feature selection is just trying to, if we really had like 30 or 50 columns, we would like to identify which ones actually, have the most explanatory power. account for the output column that we're interested in. So I'm just selecting some options here, and we're going to draw a feature importance plot to, for 4 bars. Go ahead and let it run. And now we're using the F statistic as kind of the primary measure here, and we're seeing no surprise. In fact, let me sort this largest to smallest. So petal length and petal width are by far the strongest predictors of what the species is going to be. And that's sort of indicated across the board. And here on this feature chart, we get the same information shown to us. Okay, so having done that, then we could now go back to the data and start to use Analytic Solver's prediction methods. And I'll do something just real quickly here so you can see it. We'll actually use discriminant analysis, which is what Fisher was initially doing. So we want an output variable. We just select that and say species name, 3 classes, categorical variable. And these 4 will be our selected variables that are predictors. And now we can select options just in terms of what we want to see. I'm going to skip the partitioning step this time, although I'll use it in a moment, and then go ahead and run this. And at this point, we're going to get some fairly simple results here. Probably the most interesting part is just this training score. Remember, we just used all the data, but you see that this is called a confusion matrix, and it's actual versus predicted. So the 50 actual setoses were all correctly predicted as setoses. We made only a couple of errors. Those will be off the diagonal. So a couple times the actual versicolor we predicted to be virginica. And similarly over here, there was one virginica that we predicted as versicolor. And 98% prediction. Well, this is a pretty well-behaved data set. Okay. So now this is a very simple data set. Doesn't show us too much. So I'm going to go ahead and move on to this wine data set. And as we talked about before, this is it's from a UCI machine learning repository. It's a situation where we actually have like 170, 180 roughly examples of wines from 3 different wineries, A, B, and C. And we're looking at the different sort of chemical characteristics of those data sets. Now, if we did the same thing again, I'll just tell you that the chart wizard would be a little harder to figure out, like which, not so many obvious clusters or anything like that. If we go ahead and do feature selection, again, we want to use type as our output variable, and everything else is a measurement that we want to include. So moving those over into continuous variables and going to next. I'll pick again these same statistics, just see them all as just measures. And I'll go ahead and again create a feature importance plot. Now it's a little more of a surprise to see what are we going to get. And here now we see that, alcohols, these are not yet sorted, so let's go ahead and sort them again, largest to smallest. We find that flavonoids and proline are our 2 strongest predictors. And I don't know what this OD280, OD315 is, but it's not a bad predictor also. And then if we look at top features, we see these showing up for us again. Now, okay, so now let's try to actually build a more serious predictive model or a classification model. So I've mentioned that we typically want to partition the data first. Now I'll do that as a separate step here. You can actually partition on the fly when you're in the middle of one of these classification methods. Right, this time we'll partition as a separate step. So I'm asking for a standard partition. And at this point, I just want all the variables selected. I don't want to omit any columns. And what we're doing here now is all we're doing is randomly selecting rows and putting them into the training set or the validation set. We want a little bit larger training set, so we're using 60% of the rows for the training set, 40% for the validation set. So go ahead and do that, and it actually generates for us a new worksheet. And in that worksheet, we've got this partition data. We've got the training set followed by the validation set. You see we've assigned row numbers, but we have randomly selected training versus validation set. Now that we have that done, we can go into classification, and this time we'll build a classification tree. This is what's sometimes called CART, C-A-R-T, classification and regression trees. This is, in this case, a classification exercise. So we're going to classify as A, B, or C. So type is our output variable. Record ID was appended, but we don't need that. Everything else is a selected variable. These are all continuous, not categorical variables. Okay, and so now we can say next. Notice that we're just training on the training set. And now this is going to create a classification tree, also called a decision tree. We are already partitioning. And in this method, we have some additional choices. We can build the tree using the training set, and then we can actually prune it using the validation set, which typically makes the tree smaller. And then we'll use the best pruned tree as our final scoring model if we're going to do future scoring. We'll show feature importance, and then we actually want to see the fully grown tree and the best pruned tree. Okay, and then we'll go on and we'll just produce a summary report. So let's now let it run. You notice that the whole thing runs rather quickly, and you'd see even if we were building an ensemble of 40 different classification trees, it would still run quite quickly. So here again, we see feature importance, and we'll again sort this from large to smallest. Since I think we should do that by default, but proline, color intensity, phenols and flavonoids popped up for in this algorithm, in this method. Uses a little bit of a different approach. Over here, we'll have the confusion matrix on the training set. So we made, again, just a couple of errors. Most were correctly predicted, 97% corrected. But now remember, we had held out data that the algorithm was not trained on. That's the validation set here. And now the predictor, the classification algorithm worked pretty well, not as well. You can see we had made more errors. In fact, we had an 84.5% accuracy. Over here, if we go on this tab, we can actually see the classification tree. So you see it's actually testing proline first. So if it's testing for a new observation to try to classify it as A, B, or C, test proline first. If it goes, we go left if it's less than 730, go right if it's greater than 730, then we test color intensity. 64 observations went down this path, 43 on that path. Then we test color intensity, then flavonoids, and then we're able to make a classification. Now notice that that's got 6 nodes in it. That is the fully grown tree. And on this tab, we have the pruned version of that thing, the best pruned tree, which is only 4 nodes instead of 6 nodes. But we'll still have very good prediction qualities. And then one more thing to look at here real quickly is this is the trained model with all of the fitted parameters in here. You can see some of these parameters, like these are the branching values. And this is expressed in what's called PMML, Predictive Modeling Markup Language. It's an XML-based format, as you can see. And this is something you can export and use in other software, actually. If you ever want to do that, just go to, well, you can actually just copy and paste from here, or there's an option under Analytics Solver Deploy Model you use Deploy Model Quick Test, and then Fitted Model here, and that would just save your model as a local file. Okay, so that's a little bit more of an ambitious example. Now, I mentioned earlier that, I'm going to go ahead and I'll just keep this one open. But I mentioned that apart from doing this kind of machine learning model fitting, where you're using, you can think of another method that's actually available under classification here is logistic regression. Under prediction, we have linear regression. You've probably heard of that. That's designed for cases where we have multiple independent variables to predict some single outcome. Now, something that arises in practice a fair amount is you have what we would just call time series data. And I've got an example of that here. This is actually from a famous Box-Jenkins paper on time series forecasting. And this is airline passengers per year, and it's in thousands, I think, starting way back in 1949 and going way almost up to, well, 1960. That's when Box-Jenkins published this data. And you notice that there's only two columns. There's a time, a month in this case, and there's a quantity. So what do we do with that kind of data? Well, we can explore it, use the chart wizard now that we're just really plotting a regular old line chart. And the variable that we actually want to plot is the number of passengers, but then also we have an x-axis selection number of months. And so, and then we go ahead and plot this. And we do see something that's kind of interesting. You can see that airline passengers has grown steadily over many years. And that's not a surprise to us who have flown on the airlines, but that there's also a pretty strong seasonal pattern that repeats every year over, in fact, a 12-month interval. And that is related to, spring, summer, fall, winter, just the pattern of traveling at that time. This, of course, is all pre-COVID as well. And I'll point out one other observation here, that the magnitude of these seasonal fluctuations are not constant. They grow as the underlying trend, as the magnitude of the numbers grow, okay? So I'm gonna keep that in mind. And now I'm gonna go directly to this time series here, and I'm gonna skip partition. You can partition time series data to get a better fit, but I'm gonna move in ARIMA. These are autoregressive integrated machine, autoregressive integrated moving average models. There's a whole range of models you can create this way. I'm going to, because this is well-behaved seasonal data, I'm going to use exponential smoothing, and in particular, I'm going to use the Holt-Winters method, multiplicative, and that's because the magnitude of those seasonal patterns were growing. I'm going to use that, and so now I just have to set up my variables. So the selected variable is passengers, and the time variable is months, just as we expect. And I'm telling it because I know that it's a 12-period seasonal pattern. And I'm asking it to optimize there will be three parameters, alpha, beta, and gamma. And as part of the whole forecasting method, it's supposed to optimally fit those parameters. So now I can go ahead and do that. And I get a plot, and we won't spend a lot of time on this, but you can see that I get quite a tight fit for this seasonal data. But a lot of that depended on the fact that I chose, a method that would use would expect seasonality and multiplicative pattern. Okay, now there is more you can do, and I think I'm going to try to show you this at this point. There's more you can do, and by the way, you can always go in Analytics Solver to, of course, help, and there's a whole help center here, user guides, example models, and so on. Plus, you can go directly to a drop-down menu, but we'll just go here again to example models, and I'm going to the forecasting data find models, and we just looked at AirPass, this one here, AirPass. We previously looked at Iris from here, that's the flowers, and the wine example here. In Analytics Solver, you can not only run these individual models in one step, but you can create multi-stage workflows and automate that work. So here is an example where, see if I got the right one open here. This is called AirPass Workflow. It's the same data, but I actually now automate the steps, source data, fit exponential smoothing, and then score new data. And you can construct this multi-stage workflow either by turning on this recorder and then just performing the steps using the data mining menus here, or you can actually drag and drop, like if we wanted to add a partitioning step in here, a time series partitioning step, we could drag this over here, and then it's going to ask me to, select my variables, which I'll do. I'm sorry, one of these is a time variable. Put that back under time. And now it'll actually get connected for me, but I can insert it in place like this, and I can connect one to the other. So and notice that some of these examples do have associated videos that you can just open and go through them quickly. There is another example under example models of something that's not a time series. This one, Charles Book Club workflow, actually is, you know, the kind of model where we train like a classification or prediction model, and you can actually widen this. Now we are actually choosing source data, partitioning the data, and using two different methods here: discriminant analysis and logistic regression, and then scoring. So all of that you can automate as well. Okay, now we've been talking quite a bit about Excel, and we're halfway through here, so I want to come back to the slides for just a minute and move into the topic of you know, going beyond just working in desktop Excel and talking about creating a cloud service. And I'm going to be a little bit limited in terms of actually demonstrating the cloud services, but let's spend a little time just on the background. Those of you who have been at previous webinars probably, hopefully at this point, will be familiar with the idea, but we have enough people arriving new in these webinars with Excel-based experience, but limited experience with cloud services, that's a bit of a mystery to people. So to go over a few of the basics here, what is a cloud service? A good way to start from that's familiar is that we're all familiar with using a web browser to talk to a web server over the internet. So, you know, you start in a browser, and in fact, for this session, you click a link to go to the GoToWebinar or GoToMeeting web server and fire up a client that allowed you to connect to this meeting. But to take an even simpler example, you open your web browser, whether it's, you know, Chrome, Firefox, Safari, Edge, or whatever. And remember, that's just a program running on your local computer. And then you type in a URL or like solver.com, and that instructs this program to go out over the internet and make a connection to a server to be found at solver.com, and then translating through the so-called domain name system, which is another internet-based database lookup. Basically, it translates solver.com into the specific machine address or IP address where the server is located, and the Raison server, which is, it's solver.com web server, which is traditional web server, is a program running on some kind of server. The important thing is that it is connected to the public internet at this address. And so the web browser sends a command using the protocol called HTTPS. HTTP is Hypertext Transfer Protocol. It's the fundamental protocol for the web. The S is the secure version. And like to just fetch the home page, you'd say get the page at solver.com, you know, and no following URL. And to move from page to page, when you click a link, then that typically causes the browser to issue a command to say go get solver.com, and on that web server get the page that is named say Analytics Solver Platform or something. A post occurs when you fill out a form, for example, on your web browser and enter some data. Then the browser will send a command, a request called a post request. And in the body of that request, there will be the values you entered in the form, and those will be sent to the web server, which will store them or use them to create an account or something like that. Footage used actually to update previously posted information. And the server is responding again over HTTPS. It's sending an HTTPS response, and the contents of that response is typically HTML, hypertext markup language, with CSS cascading style sheets as a way to like style and format and color the information that gets shown. And it's the web browser's job to interpret HTML and CSS and display things on the screen. And a third element here is on essentially any web page, you can have hypertext transfer, hypertext markup language, CSS, and JavaScript. JavaScript code right on the page, which then can be executed in the browser to do fairly simple things like animations and selectively showing and hiding things and so on. So you can even do more powerful things. Okay, so when we talk about a cloud service, we really just generalize that story. Instead of saying that the only client could be a web browser, we say client can be any program that is willing and able to talk these protocols, namely send and receive messages over HTTPS and send these particular commands, get, post, put, and so on, and get a response that based on a common standard that we'll understand. So the program over here serving as a client can still be, Chrome or Firefox, but it can be a mobile app, it can be a Power App, it can be Power BI. And over here now, the server can be any, again, it's a program running on a server that's connected to the public internet at all times, and it's listening on, for messages from HTTPS requests over port 80 in the case of HTTP, and typically it has to be able to service many requests that might come in overlapping at once, but it's then able to respond to these kind of commands, and it's the same commands. But the point here is that instead of something happening because you're looking at a screen and clicking links and so on, this can all happen under this program's control, the client's control, to ask for things, and this server can then perform work and send responses back. And typically now, instead of sending back something to be visually displayed like HTML, we send back data, and the most common form of data is called JSON, JavaScript Object Notation. Okay, so that's what happens in a cloud service. Hopefully that's pretty clear. Now, to try to show you that at work, I'm actually gonna, instead of trying to run a machine learning model here, I'm gonna try to run something simple. Let me also try to just illustrate that we've been using desktop Excel here, but there you can also use Excel for the web. Over here, I actually have a workbook open. It's a standard workbook with a little optimization model. And I do have Analytics Solver on the ribbon here, and I have the data mining tab on the ribbon here as well. And actually, I can bring up the same examples here. Seems like it frequently wants to update the add-in. Okay. And let's see, I should be able to bring up example models. And it wants me to check out my license for use in the cloud version instead of the desktop version. So now I can bring up the same examples as before. Here's that AirPass example. And now we're actually creating a new workbook on the server on OneDrive. And we have this same example here. We can go to data mining, and we can go to exponential smoothing like we did before, and go to Paul Winters, and select the same things. This one is the time variable. This one is the input variable, 12 periods, optimize the parameters. I think I did all that right. And go ahead and let it run. But now the way it runs is it actually sends this off to the Rayzon server and brings back the result. And let's see, it's taking a bit of a time to do that. And I hope this isn't going to be in my way. Okay, it's come back, and it has it's given me these workbooks stored in the workbook and similar results to what I had before. And again, we have a stored PMML model that we can use later. We probably don't have quite all the same pop-up charts, but we are able to run all the same algorithms from the browser, from Analytics Solver running in the browser. Okay, so now let me come back to PowerPoint here. So we talked about what is a cloud service and how this works. And so now this is one of Seema's elaborate slides showing the Rayzon server, which actually lives at its own domain and URL. It's rayzon.net. It's an Azure hosted platform that just it computes things. It runs optimizations, it runs simulations, it runs trains, and runs data mining algorithms. And then different applications, including Analytics Solver cloud version, Analytics Solver for the running in a browser, can talk. It talks to the Rayzon server to actually run these models. Web apps, mobile apps, and other things can also talk to the Rayzon server. And then we have this front end of ours called Rayzon.com that can talk to the Rayzon cloud server. So, so something we can do from here. Let's see. Let's pick one of these workbooks where we created a classification regression tree model, and let's just see how we would move this into the Rayzon service. So we go to Analytics Solver and deploy model, and we would say cloud service, and we would now say fitted model, and it finds the PMML model, or that's on somewhere in one of the worksheets on this workbook, and then we'll go ahead and I just say save, and it will actually save it to the cloud, and it's actually stored it here, and you can see the same PMML model that's here. Now I'm going to be a little bit, I'm going to find it a little awkward, so I'm just going to skip it. Trying to run this model from here to, but you can run this model from here to score some data. And actually, the way you actually do that is, once you know the, it's a bit of a long story, but once this model is posted to the Rayzon server, which it is here, you can then make a call, which would be HTTPS post, and in the post body would be the new observation that you want to run. Like we have a new row, like one of these rows with all that sample data. That would be in the post body. Think of it very much like supplying the values from a form. And then you would call Rayzon.net/API/ and then all you actually need is this model name, and the model name is tree model here, and then a slash, and then score. And then you would get back an HTTP response that would give you a classification, A, B, or C, for the sample data that you passed in. Okay, let's see. Okay, so let's see, we're at 11:47. I'm going to try to, let me, by the way, pause for a minute here and just check on questions. I don't see any new questions. Okay, so so now I'm just going to try to summarize what we have seen so far. We talked about Analytics Solver and the fact that you can use it on desktop and in a browser. And it's worth mentioning one more time that Analytics Solver Desktop, which is what Microsoft calls a COM add-in, the traditional kind, runs only in Excel for Windows. Analytics Solver Cloud, which is what Microsoft calls a modern Office add-in, is actually served. The add-in's served from the web whenever you need it, served from the cloud, and generates those, like the ribbon that you see. Whether you're seeing it in the browser or in desktop, Excel for Windows or Excel for Macintosh. So my message here is that the Office add-in version will actually run all three places: Windows, Macintosh, and browser. It is true that if you're in Excel for Windows and you had both installed, if you had Analytics Solver Desktop and Analytics Solver Cloud installed, the cloud version defers to the desktop version under the idea that, well, you'd rather use up compute resources on your own machine if your own machine is powerful enough to do that. Okay, so as you have seen already, Analytics Solver can perform pretty powerful forecasting, data mining, machine learning operations. One thing we didn't talk much about, but there are examples available in Analytics Solver is the text mining facility. So if you have text that might either be like a typical application is you have maintenance reports or field service reports where there were a bunch of measurements taken on some instrument that field service went out diagnose or fix. But there's also some handwritten notes that then got, digitized. But all it is free-form text. You can take that free-form text, and using the text mining options, you can analyze that text. And actually, the whole idea is to convert the text into additional columns of numbers that you can then use in all the other data mining, machine learning methods. And that's done using word frequency and clustering the words together in certain documents as opposed to not being together in other documents, and that sort of thing. That's how text mining operates. But in addition, with the same software, you can solve a wide range of Monte Carlo simulation and risk analysis problems. You can solve pretty much the full spectrum of optimization models, from conventional to stochastic optimization, from very small to very large models. We have some customers with half a dozen decision variables, and others with 2 or 3 million decision variables in a single model. Excuse me there. And you can do all of that. You can do a surprising amount actually in Analytics Solver Desktop. But this is still all about kind of the desktop, and it's a scenario where once you build the model and you're running it, then it's sufficient to let people look over your shoulder, or let people look on a projection screen, maybe in a conference room, at the results that you have. Nowadays, there's a lot of us are using Microsoft Teams, and in fact, you would find under deployed model, the very first option here is Teams, and really this is very straightforward to do, and we're just giving you instructions on exactly how to do it. We're going to add a little bit more refinement to that soon, but that's a pretty good way to share the results of your model across people who might be remote from you, within your company. But you can go further in that you can share your model through Power BI, through Tableau, or build your model into a custom application. That's where Rayzon becomes a very powerful tool. It can run, it can train you can train any kind of machine learning model, and then apply that model in scoring. You can run virtually any kind of optimization model and apply that model, rerun it whenever you want to do. Run almost any kind of Monte Carlo simulation, and you can create multi-stage flows of those steps. Like on this, as illustrated on this screen, you can, like in this example, actually, we start from some data. We have an early step that partitions the data into like training and validation sets. In this step, we're actually rescaling the data because it wasn't the right scale to begin with. Then we end up with this rerunnable step, which is this rescaling step. And then here we actually train simply a multiple linear regression model, and then we can have this whole workflow. This is simply a data mining or machine learning workflow, but we can rerun that on command at scheduled times, or arrange for it to be kept up to date all the time. And these multi-stage flows can include, the same flow can include, everything from a SQL operation to a partitioning or like a missing value imputation step, or a machine learning model training step or prediction step. But it can also include, you can feed those results into an optimization model, make a decision, and then feed that into like a Teams app or a Power BI app. And actually, since, as you can kind of imagine, once we're dealing with a cloud service, questions arise about where do we get the data to regularly update the models. So Rayzon has very rich facilities to connect your model to a variety of data sources in the cloud, like Microsoft OneDrive, probably more importantly, well, SQL Server on Azure. It's a very common source. And the Microsoft Common Data Service, which underlies Dynamics 365. So Rayzon works very easily with Dynamics, and also with Power Platform, Power Apps, and Power BI. And the CData Cloud Hub, which we also support in Rayzon, we have a license from CData that allows you to access about 120 other data sources, like in this example, Google Sheets or Salesforce.com or something like that. There's also a whole set of facilities for for managing security and governance of these kinds of shared models. Rayzon's actually very strong on that count. Okay, so next steps, I want to, first of all, you can always go to solver.com and download a free trial of Analytics Solver. That's a very good step if you haven't done that already. You are also welcome to go to Rayzon.com, and I'm just going to head and click there, and you'll notice that this is bringing me right to help. There's you can access this help just by going to Rayzon.com and clicking on help, and you can actually download the full PDF user guide and reference guide without even registering or logging in or anything. And there's quite extensive help here, as you can see if we sort of step through some of these many steps. You can get a very good idea of what's possible with Rayzon. You probably already know that there's very extensive documentation available in Analytics Solver here, so Help Center user guides, and you can open any one of these. Like this is the full Analytics Solver user guide, and this will open a 10 megabyte PDF, which you can press download and save on your own computer, and make use of it that way. So those are pretty reasonable next steps. And then finally, contact us. You can use the live chat on essentially any page of solver.com. There's a live chat button up here, and often in the site when we have a sidebar, it's also here. So this will pop up, and you might get a answer bot first, but then you can get to a live person during our business hours on the West Coast. And then you're welcome to email consulting@solver.com. If you want technical support, it's better to email support@solver.com, because that will create a support ticket directly in our help desk system. But if you specifically want to talk to Dr. Seema Malecki, consulting@solver.com is sort of her generic email address. I am also CC'd on that, so I'm kind of monitoring the activity that happens on that score. Okay, so let's see if we have any questions. I'm looking in the question box. I still don't see anybody typing in a question, but I'd be happy to take any questions. And you can also, if you see that little symbol to raise your hand, I can unmute you. And we've got about 2 or 3 minutes left here. Anybody with questions? Well, there's one more thing I would like to mention. If you have not already seen this, there is a handouts, sort of little arrow you can click. And if you click on that, you'll see a PDF you can download. It's called Analytics Solver plus Rayzon Product Brief.pdf. And I'd encourage you to just click that and save it on your own computer. That's something that you can kind of usefully show to other people. If you're just discussing internally what Analytics Solver and Rayzon are all about. Okay, so I'm just still standing by for questions, and let me actually also check. On my side, I see a chat and also a question area. So let's see. Okay, and I see a thank you. Sure, thank you very much, Cesar. Okay, I think we're at a wrap. I think there don't seem to be any new questions. So let's go ahead and end the webinar. It's in Pacific time, it's 11:59, so we're right at the hour. So thank you very much for spending this time with us. And again, remember that you can go to solver.com. It's actually solver.com/webinars, and find out about upcoming webinars on optimization, none on simulation and risk analysis.